I hope that this video will be really the final video about that say mixer circuit. We start again with the decoupling. Of course that's kind of stupid, but anyway, much more info in my earlier video, so I try to draw this as quick as possible. 100 microfarad, 100k, 100 nanofarad and 12 volt. Okay, here is that say coil that was inserted in the, I draw here a fixed line, but it is a ferrite core, so that fixed line is not okay, so this is ferrite. And this is going to the transistor that was in earlier videos. This is also in earlier videos, etc, etc. Here we have that 455 kc coil, and that coil has a certain bandwidth for AM AM amplitude modulated signals. The bandwidth is approximately 10 kilocycles, and I have a lot of coils here, and at the moment I cannot find here a IF filter for say 10 kilocycles. The core is in general white, but it doesn't matter. On the other hand, when we look at the radio theory, this is another, say, IF coil with a bell-shaped ferrite rod in a certain way, with certain windings on it, and here is a hole, and in that hole there is normally a capacitor. I have, say, taken that out and changed it by an other capacitor that's here. It is, say, 22 picofarad, 12 picofarad, 12 picofarad. So that means, of course, that such a coil does not work on the original frequency where it was made for, but on a higher frequency anyway. So the most important thing that I wanted to tell here is that you can use a field effect transistor here. And the good thing of that field effect transistor is that say 100 ohms here, say on 12 volt it's 2K2, and here we have a small capacitor of say 1 microfarad. Here we take the signal out. That output capacitor can be in the range of, so sorry to say, 470 picofarad up to 100 nanofarad. That depends a lot, and this is the source, this is the drain, and here we have the gate of that transistor. That transistor is I want to go back to my earlier videos. That will take some time, but anyway, I've published it all. Drain, source, gate, drain, source, gate, and it is the BF256B or the BF245B. That BF245B is a little bit obsolete, though it was an extremely good field effect transistor. So this is more or less the modern part. I absolutely don't know whether that is true, but anyway, I ordered on the World Wide Web transistors, the BF245B, and I got the 256B, and after testing it, they worked very properly, just like the 245B. And the BF245B has 3 variations: the A version, the B version, and the C version. Both of these transistors, field effect transistors, they are FETs. This is also a FET. Are, say, vulnerable for static charges, and the BC547C was the less vulnerable. So it is more or less the big boy that can do the job, the BF245C, and the BF256B. I don't have more experiences with it, but anyway, here we have, say, the mixer. Much more information in the earlier videos. Front end, etc., etc. But the interesting thing is that we have here a field effect transistor, the BF. Say the BF245B, and its equivalent, and we can say connect here the 455K IF filter with its A key 1K resistor here, etc., etc. More in the early videos. It's a, say, frequency dependent circuit. It has a bandwidth of approximately, say, 10 megahertz, 10 kilohertz, and that's a good thing, etc., etc. Anyway, you can use in a very good way this field effect transistor, this FET, because of its endless impedance on its gate. That field effect transistor will surely not deteriorate the properties of the band filter. So here we go to ground. Here we can directly go to the gate, and that's quite strange, because we have here, say, an endless impedance between the gate and the ground. This is ground, and well, because of the good properties of this transistor, field effect transistor, you can do that. You can also use here a capacitor. In fact, it doesn't matter, because the impedance here between gate and ground is extremely high, but anyway you can do it, though it is not necessary, though it's perhaps interesting. This is, by the way, a resistor going from 1K to 10K. That does not differ much, though I have to say I always use here a 10K resistor. So 10,000 ohms. It's a source resistor. So we have here, in terms of field effect transistor technology, a source follower. Well, this sets the frequency band, and of course here, after this say not amplifying or perhaps somewhat amplifying unit, we can use another frequency dependent stage to make the whole IF amplifier more, say, more frequency dependent. And in terms of frequency dependency, I mean that the bandwidth here can be, say, made more sharp. Anyway, that was all that I wanted to tell. Perhaps I have to draw the front end. Oh, I have already drawn the front end in the early video, say part 4. And well, that was more or less all. You can amplify here, after this circuit, this whole situation, the radio signals coming from out of the antenna, here, the local oscillator here, that has an important part, local oscillator, that has an important part in, say, generating the intermediate frequency, much more in earlier videos. And then here we have that, say, field effect transistor stage that is able to, say, keep all the very, very good properties of this audio filter, the IF filter, and say, after that it can be amplified more here by, say, conventional IF amplifier. There are many videos on my YouTube channel where I have explained that. Thanks for watching.